Okay, we're going to look at problem 9, 121. It's this area is going to be revolved around this axis right here, right? It'll be revolved around the x-axis, and it's going to form a solid of mass m. And so we are supposed to determine, excuse me, by direct integration, the mass moment of inertia of the solid, and we need our answers in terms of m and a and h and whatnot. Okay, so one of the first things we knew, we need to look at this equation right here. That has a k. We want to get rid of that k, right? So how do we do that? Well, we're going to say y of, what do we know? We know y at a. Y at a is equal to h. And that's equal to k over x. In this case, it's a. So therefore, k is equal to ah. So y is equal to ah over x. So I'm going to rewrite that just right here. Y equals AH over X. So we are no longer going to use this equation right here. We're just going to use AH over X. Okay. So what do we have? Our final thing is going to look something kind of like this, right? It's kind of going to be a little solid revolved around that axis. Sorry, not very to scale, but you get the basic idea. It's being revolved around that axis, and it's going to create a solid. Okay, so we need to come up with a differential element that we want to look at. And in this case, I'd say let's look at a little differential disk. So we have this disk with some little tiny thickness here. And that thickness is dx. Okay, since we're looking, we want to define the dm. We want to find the mass of this differential element. So dm is, well, how do you figure that out? It's going to be that, whoa, please. It's going to be the area times the thickness, right? So, and the area is 1/2 pi, sorry, it's not 1/2. Nix that. The area is pi r squared of that area times the thickness is dx. Now remember, but this is what? This is the volume. We don't need volume, we need mass, and so we need to multiply that by density. Okay, so I'm going to take this over here so I can start getting a little more space. Okay, so therefore dm is equal to pi rho times r squared. What is r in this case? R is going to be from here to here, right? That's going to be my r, which is also y. So it's going to be y squared times d times the thickness. So I'm going to rewrite that as rho pi y squared is going to be a squared h squared over x squared dx. Okay, so now we have my differential dm. So I know what I'm doing for my differential element. Okay, so now what am I going to do? Why did I do that? Because I know the ix of a disk is 1/2 r squared m. That just comes from the tables in the back. And then I say, okay, for this disk, I can say the dix, so the ix of my differential element is 1/2 r squared times dm, right? So we're looking at 1/2, and r is again what? I'm just going to keep it as y to clarify things a little bit, to make my life easy. Y squared, and my dm is rho pi, and I'm going to replace this with y again, y squared dx. So my dix is 1/2 rho pi y to the 4th dx. And then I can replace this y, so this is equal to 1/2 rho pi, and then it's going to be a to the 4th h to the 4th over x to the 4th dx. So how do I calculate? So if I have my differential, how do I do it? I integrate it, and in this case I'm going from a to a plus 2a, so from a to 3a. So therefore ix is equal to integral from a to 3a of dix, which is integral from a to 3a of 1/2 rho pi a to the 4th h to the 4th over x to the 4th dx. Okay, so I'm going to pull out all my constants. So we're looking at from a to 3a. So I have 1/2 rho pi a to the fourth h to the fourth, and then it's just integral of 1 over x to the fourth. Okay, so that works out to be, by my fancy calculus that I did offline, it ends up that you get, I'm kind of cheating a little bit and doing, I'll pull out the negative sign, okay. 1, it's going to be 1/3 times 1/2, so minus 1/6 times rho pi a to the fourth h to the fourth times, and we're going to have 1 over x cubed evaluated from a to 3a, and when you put in that, you end up with, I'm going to cheat here. I don't give a final answer for right now. I'm going to say 1/6 times 26 over 27, because your a cubed is 27, you end up being 1 minus that, rho pi a h to the fourth. Okay, so my ix is that. Okay, this is what I want. This is why I'm doing this video, is I want to talk about this for a second. That is the answer. You're done. But you're not really. But that is an answer. That is a totally valid, legitimate answer. But here is the problem. They said express your answers in terms of m and the dimensions of the solid. Okay, so right now we have this pesky rho hanging out in there. So we don't know rho, but we know that this thing has a total mass. So what do? Well, we're going to come back to this, and we're going to say the mass is integral of the dm, right? If you integrate the dm, it's that. So therefore, mass is integral, and again, from a to 3a, and we just did dm right there. It's rho pi a squared h squared over x squared dx. So you end up with mass is equal to 2/3 rho pi a h squared. Okay, so that is my mass. Okay, fair enough. I have answer pi in there. But what I want to do is I want to get this row right here, and I want to put this row right here, and I want to use those in between. But I'm looking at this, and actually I have rho pi a h to the fourth. And so I can look at this section right here and almost just pull it out of this section right here. So I'm going to solve for rho pi a h squared is equal to, and so you just multiply, so it's 3/2 m. Okay, so given that, I can plug that into here. Notice that this is h squared up here and h to the fourth down here, so therefore I'm going to say this is 1/6 times 26 over 27 times, and I'm going to replace this rho pi a h squared with 3/2 m, and there's still an h squared floating around there. So this ends up being an answer of, I had it written down, it's 0.241 mh squared. So that is your Ix. Okay. Boom. So you have, that looks like an Iy. That's your Ix. Ix is 0.241 mh squared. So again, this, it's a valid answer. That's absolutely correct. It just happens that they want the answer in terms of masses. And so you have to get rid of that row, and you have that from actually integrating the mass up here. So that is the first part. That's part A. Okay, we're going to do now Iy. And what do we know about Iy? Well, Iy, I'm going to do a little bit here, and then I'm going to scroll down a second. I'm going to say Iy is the parallel axis term. So what do I know about Iy of that differential strip? It's Iy bar plus x squared times mass, right? But we're dealing with diy is diy bar plus x squared dm. Okay, so we're looking at, again, this little differential strip right here, and we're saying that we know that. So I'm going to scroll down here so I have some space to do this. Okay, and so I'm going to rewrite that down here. I'm going to say diy is diy bar plus x squared dm. Okay, and do we know what DIY bar is? Well, we look it up on the table, and it's 1/4 r squared dm plus x squared dm. Okay, so we are in good shape. So we're going to start plugging in what r squared is and dm and stuff like that. So you end up with 1/4 r squared. And dm is, we just got it, remember dm is right here. And so dm is pi, rho pi r squared dx. So I'm just going to write rho pi r squared times dx. And this is going to be plus x squared times rho pi r squared dx. Okay, so I can start simplifying this, and I can pull out the rho pi dx, and you end up with 1/4 of r to the 4th plus x squared r squared. Okay, so then I'm going to plug in what r is. Well, r, again, is what? It's this right here. It's the equation of this y, which is given here is ah over x. So I'm going to plug this. It looks like, so rho pi dx times 1/4 a to the 4th h to the 4th over x to the 4th plus x squared times r squared, which is a squared h squared over x squared. So you'll notice that cancels. I'm going to pull out this out of both of them. So I'm going to say, again, diy is rho pi a squared h squared dx times 1/4 of, this ends up still being a squared h squared over x squared. Sorry, that's x to the 4th. Can't read my own writing. X to the 4th plus 1. Okay, now I'm running out of space, so I'm going to come back up here. And so I'm going to start integrating that out. And I want to integrate from a to 3a. And so you end up getting rho pi a squared h squared. I can put that dx in there while I integrate it out, and you end up with 1/4 bracket 1/4 of then minus 1/3 a squared h squared over x to the minus 3, or x to x cubed plus x, and all this needs to evaluate from a to 3a. Okay, and it is, okay, again, rho pi a squared h squared. Inside here, you end up with minus 1/12 a squared h squared over a cubed times, this is 1/27 plus 3a, all that minus, so the minus and minus is going to be a plus 1/12 a squared h squared over x, a cubed minus a. Sorry about the mess. Okay, so this is, I'm going to back up just a little bit, rho pi a squared h squared, and if I'm not mistaken, the math works out to be 1/12 times 26/27 times h squared over a plus 2a. Okay. Again, although true, not a particularly clean answer, but it's a true answer. But remember, we have this rho in here. So we're going to say, hey, what can we do with that? Well, hey, I remember what I did with that. Up here, I said, I took this right here, rho pi a h squared. So I could just solve for this for rho, but I can actually get rid of a lot of unknowns in one fell swoop right here, get rid of a bunch of pi's. And so if you look at this, I only have one extra a in this. And so this right here, minus the extra a that this is not squared, is 3/2 m. So I'm going to say 3/2 ma times that number. I'm not going to rewrite it. is our final answer. So y ends up being, it can simplify down to mass times 3a squared, because a goes through and this a cancels that one, and the other one, it ends up being kind of an obnoxious number, plus 0.1204 1204 h squared. So that is the final answer that we're looking at. So it's a bit of a problem. I mean, there's no one thing that's terribly hard. You just have to kind of keep track of it. Again, this is, again, to go back to beat the dead horse, that is a fine answer. It just happens to be not what they asked for us in this problem. They want to get rid of that row. Same thing with this. Where'd it go? The answer is this answer. That is a true answer. It's the right answer, but it has that row in there. So if you want to get rid of the rows, you have to go back to knowing that the mass, you can calculate the mass by integrating the differential mass. The mass has the row floating around in it. Turns out the pi cancels things out nicely too, which is just convenient. So you can plug those rows into there, and you get your answer. And there you go.